everyone! We've seen the effect of sound on solids, such as the balloon drum head and the salt. Let's take a look at the effect of sound on a liquid, such as water. We'll need just a few supplies: a large bowl filled with water, a tuning fork, your science log, and, if you like, food coloring. The food coloring helps you to see the water better, but the experiment will still work without it. If you'd like to try this along with me, please gather these items. Before we begin, let's do a quick review. What is sound, and how does it travel? Sound is vibration, and it travels through waves, specifically longitudinal waves. We saw this movement of a longitudinal wave demonstrated by a slinky. Typically, when we hear something, an initial vibration vibrates the air particles next to it, which cause the air particles next to them to move, and so on until the sound reaches your ears and you hear it. But sound can travel through other forms of matter as well. What are the three forms of matter that we have discussed so far? If you said solids, liquids, and gases, you are correct. Which one of these is the air? A solid, liquid, or a gas? Yes, the air that surrounds us is a gas. If we think back to the balloon drumhead and the salt, there we saw sound moving through a solid. To start, we need to fill our bowl with water. And if you have food coloring, you can add that too. Then, we'll take our tuning fork and test it. You can strike the tuning fork against your hand, and when it starts vibrating, bring it towards your ear, and you should hear a humming sound. This tuning fork produces a sound of 128 Hertz, which means it vibrates 128 times per second. This is so fast you can barely see it. It just looks like a blur. In this experiment, we are going to strike our tuning fork and lightly dip it into the water. Before we get started, let's make our hypothesis. In your science log, please write down this question. What will happen when we dip the vibrating tuning fork into the water? Ready to find out? Here we go! What did you notice? Did you see how the water splashed up? Take a moment and try this on your own. Be sure to write down any observations. We tried this experiment with our Sound Discoveries class, and this is how it went.
Oh.
We're going to do it one more time.
I see it shaking too.
Why did the tuning fork displace the water? What do you think? Like all waves, sound waves carry energy. When you look at the tuning fork after striking it, it is difficult to see this energy. But by placing it in a denser medium like water, the energy from the vibrating tuning fork is transferred into the water, causing it to splash up. You can really see the effects of this energy. Let's try another experiment with water. For this, we will need an empty 2-liter bottle, a pair of scissors, a bucket full of water, and 2 metal kitchen utensils. We are going to test whether we can hear sound underwater. Can sound travel through water? Raise your hand if you think yes. Raise your hand if you think no. If you said yes, you are correct. In fact, sound can travel even more efficiently through the water than it can through the air because the particles are closer together. Do you remember our experiment with the dominoes? When particles are closer together, they can exchange energy faster. The first thing we will need to do for this experiment is to prepare our 2-liter bottle. Please ask an adult to cut off the bottom of the bottle. You can also remove the cap as we won't need it. After your bottle is cut, it should look like this. Next, take one of your metal kitchen utensils and place it in the bucket of water in a position where you will be able to tap it with the other kitchen utensil. Now, let's grab our science logs and write down this question. If we hit the kitchen utensils against one another under the water while listening through the bottle, will we be able to hear a sound? Write down your hypothesis or guess. Let's put our hypothesis to the test. With one hand, I'm going to click my kitchen utensils together under the water, and then with the other, I'm going to hold the top of the bottle to my ear and place the wide base of the bottle into the water and see if I can hear anything. Let's all try this right now and then come back to discuss our findings. How did it go? If you heard a sound from the utensils underwater, raise your hand. Great! I also heard a sound. Was it louder or softer than you expected? I was surprised at how well I could hear the sound. This goes to show how effectively sound can travel through water. Here's a DIY project for you to try on your own. The next time you go into a bathtub or a swimming pool, take a couple of metal spoons with you. Try clicking them under the water with your ears also underwater and notice what you hear. Later, you can share your experience with your class. Thank you for joining me today in exploring how sound can travel through water. I'm Miss Liz from the Cincinnati Symphony Orchestra Sound Discoveries program. See you soon!